Anand, how are you doing today, sir?
Hey Paul, I'm great. How are you? How's everyone? Great to be on this platform. Starting off the year, as you said, it's really excited to be out here, and thank you for the opportunity.
Well, thank you for accepting the invite over here. I'm doing great. I don't know if anyone remembers from our December meeting. I was looking for a job, and today I have one. So I'm all thumbs up and happy. And in fact, I do have to give a shout out to some of my coworkers who are probably watching on the video right now because I shared the link to them. So uh, those are my friends over at Freight Verify. So they are an awesome team, and I can't say enough about them. They're just terrific. So that's my company plug. Anand, I'm going to switch it over to you. You can take over and give us your presentation. I'm looking forward to it. Thank you very
Great.
much.
Thank you, Paul, and the team to make this happen. Hello, everyone. As Paul mentioned, I'm Anand Bagmar, and before I start talking, I always forget to do this. One would have thought that after all these years of COVID and lockdown, you would remember to share your screen. Hopefully, my screen is visible now, and let's get started. So, I'm Anand Bagmar, and today I will be speaking with you about visual validation, the missing tip of the automation pyramid. A little background about myself. I've been working with Tools now for the past 4+ years. I've been in the testing space, or rather, I started testing more than 20 years ago, but very quickly I graduated to thinking about it as quality and not just testing. And that is a very big difference in my mind because testing is a testing team activity in various ways. But when you start thinking about quality, all different roles need to start collaborating and doing their bit to help build a quality product. So I've been part of this quality space now for more than 20 years, worked in various organizations around the world, product and services. I'm a contributor on the open source community side as well, including Selenium and various other open source tools. And with Tools, my role is of a senior solutions architect and a quality evangelist. That's enough about me. I would love to continue this conversation with you even after this particular conversation. My Twitter is mentioned on the screen. You can find me on LinkedIn as well. And I really hope to connect with you and take this discussion forward. But today it's about visual uh, validation and why it is the missing tip of the automation pyramid. So let's go on a journey to understand what that means. Okay. If I ask you this question, how would you test a pen? What are the different things you would think of? Does it write? Does the cap fit properly? Does it look good? Is there any ink leakage or something? How long can you write with it? Standard scenarios or test cases that you can think of for a pen. But is that sufficient? Is that right that we are testing the pen after it has been assembled? When in reality, the pen is made of many different components. Now, if you had an idea about these components, you would think about, does the cartridge fit the body of the pen correctly? Because if that itself is loose, then there is going to be leakage, ink leakage. Or is the cartridge of the right size? If it is too long, then it is not going to fit the base of the pen, or rather, the pen will not be assembled properly. So, what that means is if you test early, you could prevent a lot of problems that you may find later on, and you can help fix it well in time before more damage is done. Why is that important? When we are working on software, and that software could be websites or native apps, it could be anything for that matter, right? The desktop applications as well. And software is complex. It might be a very simple screen that we see on that is presented to the user, but it is complex. It has a lot of complex architecture, a lot of different components in the backend that need to speak properly with each other, and only then the user is going to get the functionality that is expected. Now, if you have to test this early, what is really missing here? We know this is a standard set of activities that you would do on this type of product, right? Or what are the different types of tests you will have, when you will test it, how you will test it. But there's something missing over here. And that part is, how is your screen really getting rendered? What was working well before continues to work now as well as your product evolves. The typical testing approach that we have for this type of solution is of the nature, or is of the type of spot the difference. What does that mean? If I show you these two images side by side and ask you, I'm going to wait for a few seconds and see how many differences you can find between these images. Okay, let's look at the answers. Did you find all four differences in this short span of time? Maybe some people did, maybe some people did not. It takes time, right? Let's take another example. How many differences do you see over here? Okay. Did you find all these differences? Now, I could have missed out on some differences for that matter as well, right? Because this is a very manual activity. It depends on how well you really understand this, how much time you have to look at these as well. But that typically is our approach to testing. To help make things easier, we automate our tests as much as we can. And this automation, we can think about it as a test pyramid, which gives us a visual way to think about what are the different types of tests you want to automate, at what layer, how many tests should be there, what type of feedback is expected from them, what is the value you expect out of these tests as well. This is a very known thing, so I'm not going to speak more about the pyramid, about the value of the pyramid itself. But if someone wants to know more, I would be happy to have a separate offline discussion with you to talk about that. Now, a simplistic view is there are three types of tests in this pyramid, but if you go a level deeper, you will notice that the web service actually can be split into various different types of tests at that level itself. And likewise for UI and end-to-end tests also, you can have different categories over there, or break it down in a better fashion to get better and faster feedback, very focused type of testing done at those layers. But that is your test automation pyramid. And we sort of understand this as a team. We are working towards implementing different types of tests to test the functionality, what we are building, and we hope that everything is fine. This automation also, of course, includes non-functional requirements as well: performance, security, accessibility, analytics, and there could be many more depending on context of your product. The part that still remains to be done, though, is the manual and exploratory bit. You still have to repeat this activity on every major release or change that happens in your product, at least, if not more often. And that can be delaying your release process, or it might also be a error prone activity because you're repeating the same type of tests for every different cycle that you have. And this approach, it is error prone because we sort of approach it like this puzzle spot the difference itself. So again, let's look at an example. If I show you these two images, how many differences do you find over here? I'll again wait for a few seconds. but wait a minute. This is not actually how we test, is it? What we test is we have one image, which is what is our expected functionality of the product. This could be in form of a requirements documents, PRDs, or design documents, whichever form we have that is applicable for your product. But we get this requirement document, we understand it well. Based on that, we create our approach to testing. We'll start creating a test strategy, test, identify the test scenarios, maybe start doing automation upfront as well, while the developers are implementing the functionality. So we know what is expected. And then when the build actually comes to us for testing, we get a new image of how the screen is rendered. And now tell me, how many differences did you find between those two images? This is what is rendered as a delivered product to you for testing. How many differences do you see over here? I could find at least five, six differences, but I actually missed, because this is a much more high resolution image. I missed some of the details over here. For example, there's one aspect that is missing over here in terms of the difference that is seen. This is the approach that we take for testing. Though this example is of images, we will see similar examples in our software products as well. For example, and I've got a ton of examples, Instagram, a native application, you see this weird rendering that has happened. Twitter, UPS, the app works great on a phone, but on a tablet, it renders very weirdly. A website, a news media website in the browser in this case, or e commerce, where the CSS is broken, banking website, airlines. And I've got many different examples of airlines now that travel has started. Again, I've seen a lot of these issues in the products. The problem is that because of our approach to testing, and for that matter, you take any of these examples, in most cases, your functional automation is going to continue to work fine because we rely on locators and we've got intelligent locators, and it's going to find that element that you need to interact with, do the action on that, and proceed. But clearly, the look and feel is broken over here. In many cases, you would not even be able to click on those. Your test also might fail because the screen is not being rendered correctly. So, the challenge over here is that defects still escape to production, and they escape to production because our approach to testing is incorrect. We are implementing tests, or we are writing tests based on what we expect to see. But what about the unknown that our test is not looking at right now? That is a big gap in our testing approach. Also, all of these issues would have been caught if you are doing your manual testing well. Your automation has worked, but you still need to go and explore the application and make sure everything is still working fine. Rendering is happening correctly. So, all of these issues could have been found manually as well. But do you really have the luxury of time? That is the problem. Our approach to testing is incorrect, and maybe incorrect is a very strong word. It is definitely not adequate. We need to get better. And that is what we are going to talk about for rest of the session. How can we get better at this? So instead of playing this game of chance and hope that our automation catches these types of issues, what can we do different at the top of this pyramid? The missing piece is the visual testing piece. How can we incorporate visual testing, which not just validates the look and feel and the user experience, but can it also do more and work in a way that will help us continue on our CI/CD journey in a seamless, in fact, a more optimized and better way? We understand, hopefully, based on the prior examples, if visual testing is not done, it will definitely lead to a loss of revenue. It will lead to brand and credibility loss. This is the age of social media. Anything goes wrong, we are all over social media trying to raise awareness, trying to complain about it, trying to get a resolution to the problem. But as a result of putting it out there, it can be perceived negatively as well. And there is a brand and credibility loss for that particular product and organization. A bigger challenge also is going to be you might end up losing your users. If I'm trying to purchase a flight ticket and if that website is not working correctly, I would not be very comfortable purchasing a ticket from that website. Instead, I will go to some other website and purchase the ticket from there. So I've lost my user, I've lost revenue, and my credibility is also suffering. This is a problem. So this is where visual testing can help, right? And if you, this is based on Wikipedia. What is visual testing? It's validating the visual aspects of whatever the screens are rendered, the layout, appearance, making sure each and every aspect of the UI is as expected as per design. Now, this is a very old definition as well, 2013. We are almost 10 years beyond this point now. Let's see what has changed as well in this time. So, if we go a little bit deeper into what is visual testing, typically it is done manually. You will play the spot the difference type of puzzle, understand what your how your product is evolving, and try and correlate with what is expected from your memory, or you have to switch context, look at the documents again to ensure everything is fine. So it is mostly done manually, and because of that, it is also resulting in a lot of challenges, like it is a very tedious activity, it is very error prone, it is impossible to scale and repeat in the age of CI CD, and that's a big problem. Now, the existing functional automation tools may help, but that is a little bit more than what it can do, right? But you will not be able to get all the differences, all the impact of the changes which are not meeting your criteria, meeting your baselines, meeting your expectations. Not everything will be possible using the traditional automation tools. So, what is the solution? If manual testing is not going to work, the solution is, of course, we need to try and automate it, right? Any repeated activity, that is the power of automation. Remove the same repeated activities or avoid having to do the same repeated activities, automate those, and get the feedback from the machines and take decisions based on the results that you see. So, how does this work? The first step is, of course, to create baselines. You need to have what is the expected behavior of your product available to the tool. So you create a baseline by taking screenshots of the expected UI. Then when you run the test against a new build, you will take the same screenshots again, and you will compare those screenshots with the baselines that you had captured earlier. And if there's any difference, you would want to be known about it, informed about it. Now, these screenshots that you're trying to compare can be for the whole page, it can be for snippets of the page as well, because maybe the whole page is not of interest, only a small portion of the page is of interest to me. A very important aspect is also about your product is a living and breathing product. It is going to continue to evolve and change. New features will be added. And as your product evolves, you would need to update different portions of your baselines, either all or a few of the baselines, depending on the nature of change, as your product is evolving to keep it in sync with what the expectation is. So these are at a very high level how visual testing is going to work. Create the baseline, do the comparison when you run the test, and of course, as your product evolves, update the baselines as well. But this also is challenging. It is not as easy as it looks. Why? Because the comparison itself can potentially have a lot of false positives or negatives. The baseline creation and maintenance could become a very tedious activity, especially a lot of open source tools. You need to manage this activity on your own, creation of baseline and maintaining that. Why is creation and maintenance a challenge? Because you need to think about different browsers. Now, browsers, even though they are W3C compliant, they still control how the rendering of the page needs to be done. That means a page may not look exactly the same on different types of browsers. There might be some subtle differences, which might mean you need to create different baselines for different browsers. You could be working on devices, which means there are hundreds and thousands of types of devices. Depending on the devices that are interest to you, you would need to create the baselines for those as well. And this is based on different resolutions and viewport sizes. So in the laptop, I'm using a 13-inch Mac Pro, but now we've got a 14-inch Mac Pro as well. Earlier we had 15-inch, and now we've got 16-inch as well. So there are different size browser windows that will be there, and you have to create baselines for each of these different combinations independently. Otherwise, you are trying to compare two different types of apples with each other. They are different. You cannot compare a red apple with a green apple. It is not going to be the right comparison for you. So you have to create and maintain baselines for all of these independently. And when you run the test, doing the result analysis and identifying next steps, what you need to do to fix those problems if there were any differences found, that is also a big challenge with all this information that you are getting. And this becomes more of a challenge because our products are very dynamic, right? Now, here are some different types of examples of products. And these are just websites, but native apps also come into the picture over here. And with these types of products, as your product evolves, you need to keep updating your baselines. There could be new features that you are implementing. The functionality could be different. There could be personalization on the pages. There could be contextual data on the page. There might be A B experiments that you're running in your product as well. There might be feature toggles that you might be having in your product. There could be so many different combinations of the similar type of functionality that the user is using based on which are the different types of users. You want to do visual validation for all these important combinations automatically. How is your automation tool going to be able to support these? You really need to think about those. And because of these reasons, because your product is a living and breathing product, pixel comparison just cannot work for you. Browser based rendering differences is one classic example why pixel comparison cannot work. But with contextual data, real time data, or personalized data, dynamic data, whether it's web or native apps or desktops or images or PDF documents, it does not matter. With pixel comparison, that's always going to be a challenge. You will end up getting a false comparison. Here is an example of a particular page where if I do a pixel comparison, I see a full screen as highlighted as differences. But if I use AI based comparison, then only the relevant changes are highlighted over here. So then, if these are the challenges of visual test automation, what is the solution to this? The solution is not just think about this as visual test automation or visual testing. We need to start seeing how AI can bring power and true value to this type of testing. We need to think about this as visual AI, not just as visual testing. And with visual AI, this means it's not just about visual testing, but how can you make your functional testing more powerful, and in the process also add visual testing aspects to this automation. That is what we are really talking about over here. So it's combining functional and visual testing together. That is what visual AI is. And for this, I want to speak about how Applitools Visual AI and Applitools Ultrafast Cloud truly add great value to teams where they see such type of challenges, such type of functional and visual issues escaping into production, which impacts the brand, revenue, and users as in the process. So, Visual AI, Applitools is the creator of Visual AI, and the technology, the way it is built, it simplifies your functional testing tremendously. Instead of writing a lot of validations, so now this is an example of a Cypress test where you're still using Cypress to implement your or test your functional flow. All the navigations, actions are done using Cypress, but then you're writing a lot of code to do the validations. Instead of that, with Visual AI, you can replace all the validations with a single call to Applitools and get the functional and visual validation done in one call. In addition, instead of having very specific type of validations, which is our traditional approach, with the visual AI approach of Applitools, you are able to get the full screen validation as well. So it's not just testing for very specific type of uh, assertions or not having very specific type of assertions in your code. You are also now able to check for things that you might not even be aware of, but which might not be working as expected in your product. A single call can test the whole screen very easily. So, Visual AI simplifies functional testing. Visual AI also handles dynamic content, which is a very important aspect. With the AI algorithms, you could choose and you could choose to have a combination of these algorithms, as we'll see shortly in the demo as well, where you can see these uh, how the AI algorithms can work with dynamic content. Visual AI can also work with shifting content, where in long pages, because of some small changes in your screen, the whole page appears to shift. And because of this, you end up getting a lot of false positives in your validations. With Visual AI, you will be able to focus only on specific aspects of the screen which have genuinely changed and ignore the shifting content. And that can add a huge value to your automation. Scaling is another very important aspect of our functional testing, especially because we want to make sure our product is usable on all the different supported browsers and devices that the users would be using or users would be accessing our product from. A typical approach is to run the same set of tests on different set of browsers or devices, essentially run the same test n number of times. If I have 100 tests and 4 browsers, I'm ending up to running 400 tests to get the feedback from your automated tests about the functionality. But why do you need to run the same test so many times? With the ultra-fast test cloud, you would run the test just once and get the feedback from all the different supported browsers and devices automatically at the cost of running just a single test. So you're getting huge coverage by using Visual AI. You're getting increased seamless cross browser, cross device coverage by using the ultra fast test cloud. And everything is happening by running the test just once. And you could run that test once on your machine or your CI machine, and you will still get the same type of results. Let's look at a demo what this really means. What I have right now is my ApplyTools dashboard on the left hand side, I've run a certain set of tests. This is what we call as batches. Batches is something, it's your suite of tests that you have run, your smoke, sanity, regression, whichever way you want to organize this. In here, on the right hand side now, you will see a summary of all these different tests that I've executed. And from a visual AI perspective, what was the result of those executions? This can give some interesting trends based on the execution that has happened, which can give you insights on certain aspects which is working well or not working well at all based on context of what different tests have run. You could group it based on OS, browsers, viewport sizes, devices, and various different ways. You would also notice that there is a pass and there is unresolved. There is no failed over here. And that's a very important distinction, and it's a very conscious choice of why ApplyTools does this. I'll explain that in a little bit. If you go to the details view, this is where you will see each test that has executed as part of this batch. And over here, you'll be also able to see its status, the name of the application, test, OS, browser, and this is a configurable field. You can choose what all information you want to have over here or not. Let's take a closer look at some examples. We'll start with a passing test. This is a media website where I don't need any tool to tell me that both of these images look different. On the left hand side is my baseline, what is the expected state. On the right hand side is the screenshot or the checkpoint that was captured as part of this test running. I'm comparing this checkpoint with the baseline and I want to know if there are any differences over here. But this test was marked as passed. If I toggle between the baseline and the screenshot that was captured, everything is different. Then how did this test get passed? That is because we used a layout algorithm, which is an AI algorithm, which says, I don't care about any content differences as long as the structure of my page is as expected, this test is passed for me. So if I do not have control over the data that is coming into my application, the minimum that I can do is make sure that data is not breaking the structure of my page. And that's why this test is marked as passed, because even though the content is different, the structure of my page is the same. What would happen if we want to compare the content as well? If I now choose to compare it using a strict algorithm, which is a very, very powerful AI algorithm, this algorithm says anything that is different to the human eyes, show that as a difference to me. And in this case, if I again overlay the baseline and the screenshot together, you would notice anything that is different to the human eye has been highlighted as a difference over here. So now the strict algorithm is saying the header, logo, everything is fine, but everything is different over here. Now, the differences could be related with data, content, images, anything. Does not matter. You will be seeing those as differences. What would happen if you do a pixel comparison? So if I use an exact algorithm, which is a pixel matching algorithm, you see that almost the whole page is highlighted as a difference over here, including the logo and the header, even though we could not see any difference over here. But there were some minute pixel level differences which we were not able to notice. But at a pixel level, there were differences, and the tool is highlighting that for you. So even for aspects where there should have been no differences, I'm now seeing differences found because I'm using a pixel comparison algorithm. So this is why pixel comparison does not work. This is one example why pixel comparison just does not work. But because we originally started comparing this with a layout algorithm, this test was marked as passed. Let's look at another example. This case, it's a native app example, Yahoo Finance app. And this was done, comparison was done using strict. Hence, anything that is different to the human eyes is highlighted as a difference over here. But now you might say, I don't have control over the data that comes in over here. So do I use layout for the whole screen? Well, that is one option, but maybe strict algorithm is the right algorithm for this page or this screen. But certain section or certain region of the screen, you don't have control over the data. Only that section or that region you could mark in the layout algorithm. And now you saw how much the pink area has reduced because of this. And with the layout algorithm as well, now you are able to see there is a genuine defect that is caught by the test using Applitools. There is some content inside this green label or this green box that is missing as compared to the baseline. And this is a difference of content missing versus a different content. Applitools because is highlighting only the area where the content is missing. And that is a very huge value add. Now, this particular screen is being compared using two different algorithms, strict and layout. And you could add more of these regions, as many as you need for that matter. There's another very interesting thing that we could use. You could also ignore certain regions from comparison. So if I ignore this region, that will not be included in the comparison at all. This is a very good case, for example, if your product is going to show ads or videos which you don't really care about. So you're just going to ignore it from comparison. So now in this particular example, I have three different algorithms being used in combination to test this particular screen. Because there were some differences found, Applitools marked this as unresolved. There is some mismatch that was found, hence it is unresolved. Applitools does not know, is this change that you are seeing, whatever differences are highlighted, is this an expected change or an unexpected change? Expected change would be when your product has evolved and your screen in turn has evolved because of that. So now your baseline needs to evolve also. Or these are actual defects that has been a defect that has been found, which means you need to report a defect and you need to fail the test. So Applitools does not know what is right or wrong, but Applitools can tell you with 99.49% accuracy if there is a difference on the screen found or not as compared with the baseline. You as a team member would know what is different about this build. Is this new functionality or is this a regression that is found? And you will come and take a decision. So if you're running hundreds of tests, you only need to look at the test which has a difference found. Applitools will present the difference to you. You quickly looking at the context will take a decision on those and move forward. If there are no differences found, that means the test is passing, it's green. You don't even need to look at it because everything is working fine. Now, in this particular case, there seems to be a defect that is found. And if you have a defect management tool integrated with this, for example, Jira integrated with Applitools, you could directly create a defect in Jira right from here. And at this point, you're going to do a thumbs down. When you do a thumbs down, now you will see this test is marked as failed. However, if these whatever differences that you found, they are acceptable differences because your product has evolved, and that is how it's going to be in the future. Instead of a thumbs down, you do a thumbs up. When you do a thumbs up, now it has been marked as passed. As a team member, you are coming and taking a decision on this. So, what we have seen so far is you're using a combination of algorithms to get the best value of your product or testing your product quality. Also, what we saw as part of these examples, you can do the same thing on web or native apps as well. Here is also an example of PDF document validation. Same algorithms will work for PDF as well. If a PDF has got 4 pages in this case, as in this case, there'll be each page will be considered as a separate screenshot and comparison will happen accordingly. But it's the same algorithms that can work across for PDF documents as well. There are many more interesting use cases. For example, if you want to test localization, is the structure of my page remaining the same even for different languages? So, a login screen for Facebook in different languages. I unfortunately do not know both of these languages, but I'm still able to do testing on those to make sure at least my product is working correctly. I cannot read the content and validate if that part is correct, but at least is the structure of my page the same? My structure is not getting broken with a new build that has come across. Now, with the layout algorithm, there is a difference found over here. This content in the baseline was expected to go beyond the text box. In this case, it is not. So it is highlighting that as a difference. If I use a strict algorithm over here, you see each and every aspect of the screen where there is a language difference is highlighted over here because that's what strict is going to tell for us. You will also be able to see long pages. I mentioned about the shifting content, right? So this can lead to a lot of false positives. These types of differences will not be meaningful to the team at all. So you could hide the differences caused by displacement because of some small changes happening in your page. But as a result, the whole page gets shifted. And when it does the processing of that long page, ignoring all the displacement related differences, you will notice the number of pink region reduces drastically. And here we go. Earlier, almost the full screen was in pink. Now we are able to focus on very specific areas and find out what were those differences. A very small section of code was there, and you're able to see inside that code as well what are those differences. If I zoom out, you'll be able to see how small the code snippet was, but it was able to find out the granular differences inside that as well. So these types of checks that is possible. Your test could be about a very simple functionality or just navigating through all the different screens that you have. But in that context, you will be able to do the full functional and visual validation to make sure everything is working fine. In addition, there are many other features that might be of value. For example, if you're doing A/B testing, and there are these two different screens that you are seeing, as a result of A/B testing, you could simply you can create up to 20 different variations of the same screen, and Applitools will automatically check which variation the screenshot matches against and do the comparison accordingly. And you see with this new variation, the test is passed. With the earlier variation, there were differences found. So A/B testing becomes a very powerful feature as well. Likewise, we also have accessibility testing, which is the feature we have is for contrast advisor, where given a screenshot that you have captured based on WCAG level 2.0, 2.1, and level AA, AAA, you can choose the combination of these, and Applitools will be able to tell you how many contrast violations were there on the screen. I don't want A/B testing over here. How many contrast validations were there on the screen? You can hover over those differences and you'll be able to see what was the contrast ratio that was seen on the screen, and I'm just going to reload this. What was the contrast differences that you see on the screen, what was the expected standard for that. So in this particular case, there are no violations. Oh, there are 38 violations. So you hover over this, you see actual contrast is 2.93, expected was 4.5. So this gives you a very early indication of, as your product is getting evolved, is it going to meet your expected standards or not? Very, very valuable thing. Last important functionality that I wanted to share with you, I mentioned about on the cross browser testing. The way Applitool solves that problem is using the ultra-fast grid or the ultra-fast cloud. You run the test once on your machine. So in this particular case, if I group this by test name, you'll see that I have just two tests which I've run 9 times. One test is 9 times, second test is 10 times. But this has run on different browsers or viewport sizes or devices. And we don't need to really look very far. Even by these thumbnails, you can understand how the page is getting rendered differently in these different viewport sizes. What this indicates is, because of the responsive nature of our application that we build, the rendering is going to change based on how and where the page is going to, being rendered by the user. So you want to do a true comparison based on the real combination that is there, that the user is using. So what Applitools does is it will run the test once based on the configuration you provide for different browsers and devices. It will automatically re-render the same screens on those browsers and devices, do the visual validation for you, and get the results back to your test as part of the same execution cycle. So now your test has run once, but the results that you are seeing is for all the different browser and device combinations. And that becomes a very powerful way to get the coverage from your execution. Now, what is also very important is to make decision making easier. We've got a lot of functionality, AI based capabilities in the dashboard itself that will help you take quick decisions on the results that you find. We've got self maintenance features over here in the dashboard. So in this case, though we ran the test on various different browsers and devices, viewport sizes, visual validation was done in all those cases. There were significant differences found, but if you inspect it closely using the AI features, you will see that they've been grouped into two buckets only. If you zoom in on this, I'm going to put this side by side and zoom in on the difference. You will see that the black logo has changed to a green. Maybe this is part of my rebranding activity. So this is the expected change. I'm going to do a thumbs up. I move to the next group of differences. Over here, I see that the logo is missing. In this particular case, I'm going to report this as a defect, that logo is missing. And at this point, I will just do a thumbs down and close. And with a few clicks, I've taken a decision on all the different results in my dashboard. So these are some very, very powerful capabilities that we have in Applitools that will make it easy for you to work or to get functional and visual validations done, make your testing much more streamlined, automation much more streamlined. You continue to use the same automation tools that you have, integrate Applitools with that, reduce your code, make your test more stable, get increased coverage, and not just increase coverage on that particular test, but increase scaled coverage across all your different browsers and devices. A great place to start is to look at the applitools.com/tutorials page, where you will see detailed tutorials for all the popular automation tools. And you dig in deep, you click on any of these, you'll be able to get sample code and get started with that as well very, very easily. So this is how Applitools solves, or the creator of Visual AI solves the challenges when it comes to functional and visual testing, and provides a very easy way for teams to truly get to CI/CD, reduce the manual activity that is going on. What this now means is we are adding the we are adding eyes to top of the pyramid. We are adding user experience validation, UX validation in form of automation to your pyramid, which gives you a lot of value in your execution cycle. It helps you shift left and prevent defects from leaking to production. So now your product quality is not just about all the different automation you're doing and the NFRs, it's also including user experience validations. So to summarize, it is very important to have a holistic quality strategy for your product. Think about the test pyramid. What are the different layers of the test pyramid that are applicable to your product? And how can you automate the best for each of those layers? You have to shift left to get quick feedback, and including visual validation, visual testing in your automation strategy is, in my opinion, a very, very important aspect of your test strategy going forward. If your product has business impact, has loss of revenue or brand credibility issues because of functional or visual issues, then you have to use visual AI as part of your strategy and get that early feedback, get the increased coverage and scaled feedback from your automation. There are some references. I will share the slides with you after the session in a day or so. And I hope this was insightful. It gave some background into why visual testing is important, what are the standard approaches of visual testing, and how visual AI can solve this problem for you. So, with that, Paul, I'm going to pause and let's see if we have time for questions.
Yeah, we've got about 10 minutes of time for some questions. So I've got a few of them listed over here. And let's see what I've got over here. Um, let's see. So, well, there's always the difficult one about costs and stuff. But there's Amonili Osader. I hope I got that close. He's asking, is there an open source to Apple Tools or Visual AI?
Great question. So, there are a lot of open source tools as well from a visual testing perspective. Most of them, first of all, use pixel validation. That is one big challenge. The second aspect is I'm a huge proponent of open source, by the way, right? But in this one space, uh, the challenge of creating baselines, managing the baselines, maintaining them, updating the baselines as your product evolves is not a trivial activity. And this is where I think open source tools are still not going to are not able to solve the problem as effectively, especially if your product has got dynamic content, it is contextual, you want to run it across different browsers, viewport sizes, then open source tools will be a challenge for you. But there are alternatives if in case you do require.
I agree with you. One of the things I like about Tools is that they do have 5 different levels of validation, and all of them you went through on the demo. So if anyone is joining late, watch the video and go back and watch Anand go through those demos out there. The interesting thing about it is that with these 5 different levels, Tools by default runs at level 2. Level 1 is that pixel validation, and I believe they just have it in there just so you can see the differences between what pixel validation does and how it's really not as useful versus their second level where they're looking for more AI, smarter interactions in there on that to do the validations and find the items, find changes and differences, um, and even exclude areas, saying, okay, this area I don't need to look at. Other areas are specifically need to get an eyeball
Yeah.
on.
There are some others that we didn't cover. I didn't have time to cover all of those, but there are aspects of floating region. If there's some expected change in the layout, right, within reason, then floating region can be a great algorithm to use as well. There might be cases where the colors you might not worry about, so you can ignore the color differences as well. So very interesting algorithms that can be used contextually in combination to get the best validations.
Okay. Um, I do have, let's see. Well, there was one question. Is this recorded, from Amis? Amis, yes, it is recorded. So once this video is done, go right over to the YouTube channel. You can pick it up and watch all the way from the beginning. Um, Thank you for asking that. Alexander Green out there, it says, these automation tools to a quasi company, do they have environment department restrictions? I'm not sure how to answer that one, but Anand?
Do they have environment department restrictions? I'm actually not sure what that question means
Yeah,
completely, Alexander. If you can expand on that a little bit.
yeah, Alex, we got a few minutes here, so if you can come up with a better, a little bit more descriptive of what you're asking there, we can definitely look at that. Um, let's see. I'm trying to see if there's anything, and you see on your side as well. You can go through the questions.
Yeah, yeah, I'm going.
Looks like it's kind of like people are actually answering questions on stuff here. So
Yeah.
I'm looking for question marks.
To share how.
Anand, you brought up that point about the validations of localization with different languages, programming languages. That's actually something I'm looking at as a usefulness in our application, where we expect a certain area to be in a different language, but also some areas are supposed to stay in English, and they're like, keep it that way.
Yeah, it's
Um,
very interesting, right? The tool is so powerful, you still need a good visual test strategy. What is the type of product? What type of environments do you have? What type of control do you have in different environments? How much can you test early? What do you need to test in higher environments only? And it becomes very easy to choose this. The tool is the same, you're just having a different way to use it in all these scenarios, right? It's very interesting how different customers are using appli tools for all these different use cases.
Yep. And I think you mentioned also there's like the grid where you can run the tests against multiple environment setups and then see exactly what differences are there. Can you expand a little bit more on that?
Yeah, a simple example that I like to use is a typical cross browser testing strategy, right? If I have 100 tests automated, let's say using Cypress or Selenium or APM, any tool, if I want to run the same test on, let's say, different browsers, if I'm using Cypress or Selenium, I want to run the same 100 tests on four primary browsers, right? Edge, Safari, Firefox, Chrome. And there are three standard breakpoints when it comes to responsive design. So now immediately we've got 12 combinations that are important for me to test if my website is working well, just on the desktop browser. Now, what this means is I'm running the same 100 tests 12 times. That is 1200 tests that are going to execute. I need to analyze the results out of all of these. And most of the times, there will be some amount of flakiness, or tests might fail sporadically, randomly. You might need to rerun certain tests. So there's a lot of time that you need to run all these tests, look at the results, and make meaning out of it. Instead, if you use Tools, you are running the test only one time. So only 100 tests are going to run. If those 100 tests took 1 hour to execute, you will still run it in 1 hour plus a few minutes, but you will get the visual validation results along with that in that time for all the 12 combinations or even more. So you're getting more than 1200 test results in an hour, 10 minutes instead of 12 hours plus time, whatever is required.
And
And that's a
hopefully,
huge saving.
yeah, hopefully only like maybe 1% of it fails, so that we're looking at about 12 different defects. So that's, I
Absolutely.
mean, the scalability. Everyone always wants scalability, but when you
Yeah,
start thinking about how many test cases are you doing, uh, it can become a challenge if everything suddenly fails. And
correct.
usually when everything fails, it means your password is expired. There's a little tip for you. All
And
right.
now,
I think we're yeah, go ahead, Anand.
sorry, there's one more thing over there, right? Talking about the scaling aspect. Recently, we've released a new product for native applications as well called the Native Mobile Grid. So the ultra-fast grid is for the web, the native mobile grid is for native applications. You run the test on one Android device, you get the feedback from all Android devices for the native applications automatically. Likewise for iOS as well. So it's again a great way to scale your testing shift left for native applications.
That sounds really cool. Now I gotta go play around with that. Um, maybe we got some. Maybe if you can dig up some links to videos on stuff like that, we could share that over onto our chat.
Absolutely.
And with that, Anand, again, thank you so much for joining me today. It's been a pleasure speaking with you and taking a look at Apple Tools and how it does the visual validation. It's a real thing, everybody. I always say that there's three companies out there that do visual validations. Their names are Apple Tools, and Apple Tools. So everybody else is just pixel validation, and it's don't get all hooked into that. There are better and smarter ways to do it, and Apple Tools does a really great job at it. Anand, thank you again. I can't thank you enough for this.
Thank you for the opportunity, Paul. Thank you everyone for listening in. Again, looking forward to connect with you offline.
Sounds
Take care.
great. Thanks. Cheers.